Rainbows are one of nature's most enchanting and universally beloved phenomena. These colorful arcs of light have inspired wonder and awe across cultures and throughout history. Children and adults alike gaze in admiration when a rainbow appears, often searching for its end or hoping to glimpse a double rainbow. But behind this magical display lies a fascinating interplay of science, physics, and the laws of optics that work together to create this beautiful spectacle. To understand the science of rainbows, one must first appreciate the nature of light itself. Light, although it appears white to our eyes, is composed of many colors. This idea can be traced back to the 17th century and the work of Sir Isaac Newton, who famously demonstrated that white light is made up of a spectrum of colors. Newton used a prism to show that when light passes through a transparent object at an angle, it bends or refracts. This refraction causes the light to spread out into its constituent colors: red, orange, yellow, green, blue, indigo, and violet, forming a spectrum. A rainbow occurs because of a similar process, but instead of a prism, the refracting medium is water droplets in the atmosphere. After a rain shower, when the sun begins to break through the clouds, the conditions become ideal for rainbows to appear. Sunlight enters these tiny water droplets and is refracted. As the light continues through the droplet, it reflects off the inside surface, then refracts again as it exits the droplet. This series of refractions and reflections causes the light to spread out into the spectrum of colors we see as a rainbow. The appearance of a rainbow depends on the angle at which the light is viewed. Most commonly, a rainbow forms a circle, with the ground obscuring the lower half, making it appear as an arc. The sun must be behind the observer, and the rain must be in front of them for the rainbow to be visible. The colors of the rainbow are always in the same order, from red on the outer edge to violet on the inner edge. This order is due to the differing wavelengths of the colors of light. Red light has a longer wavelength and is refracted less sharply than violet light, which has a shorter wavelength. The physics of refraction and reflection are central to understanding why rainbows appear as they do. When light enters a water droplet, it slows down and bends because water is denser than air. This bending, or refraction, is what causes the light to separate into different colors. The light then reflects off the inside surface of the droplet and refracts again as it exits the droplet and re-enters the air. The specific angle at which this occurs, about 42 degrees from the direction opposite the sun, is what determines where the rainbow will appear in the sky. A fascinating aspect of rainbows is that they are not objects you can physically approach or touch. They are optical illusions created by the viewer's perspective. Each person sees their own unique rainbow, depending on their position relative to the sun and the raindrops. This means that no two people see the exact same rainbow, and if you were to move even slightly, the rainbow would shift and change with you. While the primary rainbow is the most familiar, there are other types of rainbows that can appear under the right conditions. The most common of these is the secondary rainbow, which is fainter and appears outside the primary rainbow. A secondary rainbow is formed by a double reflection of sunlight inside the water droplets, which reverses the order of the colors. In a secondary rainbow, red is on the inside and violet is on the outside. The secondary rainbow is typically fainter than the primary rainbow because some of the light escapes the droplet after the first reflection, leaving less light to create the second arc. In rare instances, you might also see a supernumerary rainbow, which appears as a series of faint, pastel-colored bands just inside the primary rainbow. These extra bands are caused by interference patterns when light waves overlap as they exit the water droplets. The supernumerary rainbow is a vivid example of the wave nature of light, and its appearance depends on the size of the raindrops. Smaller droplets tend to produce more noticeable supernumerary bands. There are also atmospheric conditions that can lead to other rainbow-like phenomena. For example, fogbows, also known as white rainbows or ghost rainbows, are created in much the same way as regular rainbows, but they occur in fog rather than rain. Because the droplets in fog are much smaller than raindrops, a fogbow appears as a pale, white arc with very little color. The small size of the droplets causes more diffraction of light, which blurs the colors together and results in the white appearance. Glories are another optical phenomenon related to rainbows, often seen from airplanes or on mountaintops when looking down into clouds. A glory appears as a series of concentric, colorful rings around the shadow of the observer's head, known as the Brocken specter. Glories are caused by a combination of reflection, refraction, and diffraction of light inside tiny water droplets, similar to the process that creates a rainbow but involving smaller droplets and more complex interactions. The study of rainbows and related phenomena delves into the realms of optics and meteorology, offering insights into how light behaves in different environments. The size of raindrops, the angle of the sun, and the position of the observer all contribute to the final appearance of the rainbow. For example, larger raindrops tend to produce more vivid and brighter rainbows, as they allow for more intense internal reflections. Smaller drops, on the other hand, can cause the colors to blur and the rainbow to appear more pastel. Throughout history, rainbows have been the subject of mythology, art, and literature. Many cultures have imbued rainbows with symbolic meaning. In Greek mythology, the rainbow was seen as a path made by the messenger goddess Iris between heaven and earth. In Norse mythology, the Bifrost was a rainbow bridge that connected the world of humans to the realm of the gods. The rainbow has often been a symbol of hope, a promise of better times to come, or a connection between the earthly and the divine. In more recent times, rainbows have taken on additional meanings, such as the symbol of LGBTQ+ pride, where the diverse colors represent the diversity of the community. The beauty and universality of the rainbow make it a powerful symbol in various contexts, both cultural and scientific. Rainbows also have practical implications in the field of meteorology. The appearance of a rainbow can provide information about weather conditions. Since rainbows only occur when there is rain and sunshine at the same time, they typically appear in the morning or late afternoon when the sun is lower in the sky. The presence of a rainbow can indicate that rain is clearing or that there are scattered showers in the area. Sailors and outdoor enthusiasts have often used the appearance of rainbows to predict weather changes. The scientific understanding of rainbows has evolved over centuries, beginning with early observations and culminating in the precise explanations provided by the laws of optics. Ancient scholars like Aristotle pondered the nature of rainbows, but it wasn't until the work of Renaissance scientists, particularly Descartes and Newton, that the true explanation of rainbows began to take shape. Descartes was the first to explain the formation of a rainbow as a combination of refraction, reflection, and dispersion of light within water droplets, and Newton furthered this understanding by showing that white light is composed of many colors. Modern science has continued to build on these foundational insights, using advanced tools and techniques to study rainbows in greater detail. Today, we understand that rainbows are a perfect blend of art and science, a natural display of light's interaction with the elements of the atmosphere. They remind us of the inherent beauty in the laws of physics and how they govern the world around us. Despite the advanced understanding we have today, the experience of seeing a rainbow remains a magical one. Even with the knowledge of how and why they form, the sight of a rainbow still has the power to inspire wonder and joy. It's a reminder that nature is full of surprises and that even the most familiar phenomena can hold secrets waiting to be discovered. In the end, the science of rainbows is not just about understanding how they form but also about appreciating the beauty of the natural world. Rainbows are a testament to the complexity and elegance of the universe, where light, water, and the laws of physics come together to create something truly extraordinary. They encourage us to look up, to explore, and to cherish the world we live in, a world where even a simple rain shower can give rise to a breathtaking display of color and light.